Okay, a few more things. First about handling errors with ArcGIS. Um, Try except blocks are something we haven't covered yet, so we'll cover it now. I'm going to go ahead and copy and paste this code into a new script. And what you'll see is that what I've done is I've taken and done try and except. And you'll see that everything I use to access ArcGIS, ArcPy is inside of here now. Okay? So the reason we do this is because Esri not only crashes on a regular basis, as do a lot of libraries, but Esri a little more than most, I think. And the problem is it also has its own way of passing back messages to you. So it doesn't use the standard Python exception handling. It does its own. And so I'm going to run this. Now notice that I'm actually going to give it a path and a file that don't exist. So it's going to generate an error. Oh, and we should go ahead and let's single step it because that'll be fun. Okay, so we're going to go ahead and load ArcPy. Check out the spatial extension, set up a path. Now we're going to do our aspect, which is going to generate an error. Okay? Unless I actually have a file called temp.image. Okay, so notice what happened. We're inside a try except block. Okay, so this is the code that we're going to execute. And then if there's an error, it jumps down here. Now this has happened in the past, but it's happened inside of Wing. When you get an error inside of Wing, Wing actually has a hidden try except block, and then it goes ahead and prints out the error message down here in debug.io for you. Well, now we've got to handle that ourselves because again, Esri doesn't use the standard messaging, and you're going to want this information that's in get messages because, take a look, there it is, input raster, see temp.image does not exist. So that's how we're going to be able to get to these error messages. And please wrap all of your code in a try except block. So all I need to do is put try at the start, and then down at the bottom put except, and then the ArcPy get messages. And you can do multiple try except blocks and get more sophisticated later on, but right now you just need to wrap all of your ArcGIS code in a try except block. Okay, so some other things about calling ArcGIS, or ArcPy. Finding out parameters. Now we've actually done this already, but one of the things that's going to happen is if you go to do a clip, you're going to need to have the boundary of where you're at, and we can do that by just moving our cursor around. And if you take a look down here, you're going to see there's a location of the cursor in degrees, minutes, and seconds. So this is another way that you can go in here. Now it's going to move around, so what you can do is you can just go in here and change it. We tend to use decimal degrees. Set your cursor down, write or type those notes into something where you can copy and paste them. Note that it's longitude first, right? Because it's got a W for west, and then it's latitude second. Now also we tend to have plus minus instead of north south. So remember that north is positive, south is negative, west is also negative, east is positive. So make sure you get those plus minus signs or things will end up on the wrong side of the planet. Okay? The other parameters we talked about, some of them are interesting because you might expect that if you're going to do something like a buffer, you would just put in the number of map units that you would buffer. However, Esri lets you specify meters even if the data is projected in feet. So typically you'll do this as a string. So you'll say 1,000 meters, and you put it in as a string. And again, remember to check the Esri help documentation. It will show you what the parameter type is, whether it's string or an integer. And again, there's those examples to work from. There's also the Python snippets that you can grab, and there's a source assistant. So you've got a lot of help to figure out what those are, which is good because it's not always straightforward. Okay, just a couple of notes. Things have gotten easier. I think everyone is starting to move to ArcGIS Pro, which is good. ArcMap is still using Python 2.7, which is like 10 years old. and it's really dying, and the libraries aren't very well supported for it anymore. Everyone's moved to Python 3 quite a while ago, so moving to Arc Pro is going to be a good thing if you're doing any programming with ArcPy. 2.7 still works, but we're starting to have issues with it that they don't seem to be fixing. So another note is we install Python 3. As I think most of you have seen, the Python installers default putting this in your users folder. That's only going to let you access Python. No one else is using your machine can access it. And then if someone else installs it, now you've got multiple versions. And you can really quickly end up with lots of versions of Pythons on a computer, and then you're confused about which one's running when. I tend to install everything for any user, and that means it's going to go in C program files, and I try to just have one copy of each version of Python. I do typically have, I've got 3.7, I've got 3.8, I've got both of them installed because I'm moving from 3.7 to 3.8. So I do tend to have multiple versions, you'll see that. But if I do it for any user, then there's less versions on my computer. Now, you can only do it for any user if you're the administrator on your computer. So when you go to install, you may have to right click and say run as administrator. And not all of you will have administrative rights. Like at HSU, you can't install it for any user because you won't have administrative rights. Okay, so I'm on Python 3.8. Python 3.9 is out. I don't move right to the new version as soon as it's out. But note that ArcGIS Pro uses 3.6, so it's going to lag behind a little bit. Hopefully not as bad as ArcMap did, but it's going to lag behind. I don't think this is going to be a big problem because there's not a lot of differences between 3.6, 7, 8, and 9. There are differences, but they're mostly bug fixes. The bigger issue is that Esri ships a customized version of Python. So they've gone in and modified it. I don't know why they would do this. They did this with 2.7. It creates a whole bunch of problems for those of us that are developers. I think it's the only one you can use with ArcPy. I don't think you can install other libraries into it. We've tried in the past. I've given up. Fortunately, they are increasing the number of libraries that they make available with their version. So NumPy, SciPy, Ogre, and GDAL, the open source libraries, are all there, but not Proj for some reason. I don't know why. So we're just stuck with whatever they have, and you can't write a Python script that calls ArcGIS Pro and then turns around and calls something else because it'll be using this custom version. So that's created a lot of problems, and at the end of the semester, I'll show you one way around that. By doing a sub-launch of another script. The other one is they're changing Python almost every version. As you saw, there's that DDD version. In fact, there's the old global object, whatever it was called, version has popped up again. So they're changing it a lot. I would stay with the ArcPy.sa, ArcPy.analysis, those libraries. The other ones may disappear. So I just would be careful on what you use, or you may end up rewriting your code. And I'd be prepared for that anyway, because Esri regularly changes their development environment, and they don't always warn us. When we went from, I think it was 8 to 9, there were 4 different programming supported in the ArcGIS products, and they deleted all but one of them. And so suddenly a lot of folks were left out in the cold. I don't think they'll remove Python because they're heavily invested in it, and a lot of people are using it internally to Esri as well as outside. So I think they'll stick with Python, but be ready for their version of it to change. They tend to just do that. And especially this path will probably change. They're shipping 2 versions of Python. The one that I found worked is the one that's at this path. The other one I couldn't get to work. There may be other ones in the future, or this path may change. So be ready for that. All right. So a little bit more on some ArcGIS Pro functions. One of the cool things you can do is you can load rasters by just creating an object and passing a path, and then you can get information on it. It's pretty cool. Even more cool is that you can do raster math. Now you've seen this in SpaPy, and they do it here. You can just, once you load a couple of rasters, like this, you can then multiply them together, divide them, add them, subtract them. Now remember, this is doing a pixel by pixel multiply, divide, add, or subtract. So arithmetic on each pixel that overlaps another pixel. Same thing is true for Boolean operations, only the documentation they had had us using the vertical bar. That's another symbol for or, and the ampersand, which is another symbol for and. I used to use these in C and C++, but I've gone over to the and or in regular Python because I think those look better. And then they have the Boolean operations, again, working on pixel by pixel to say, are they equal? Remember the double equals. That burns folks a lot. Not equals, less, greater than or equals, less than or equals. And then you can go ahead and save it. So you can do a bunch of raster math and comparisons and other things and then save it out. Pretty cool. And then there's a bunch of other functions. These are structured kind of like SpotPy. Same idea. And again, you can input a raster and then a raster or a constant or a scalar value, either one. So flexibility here. And a bunch of different functions, including those Boolean and ones. And this is just a subset. This is kind of what I have been using to give you an example of some of the functions that are out there. There's a huge number of functions. And the way I typically find them is by going into ArcGIS, finding them in the toolbox, and then using one of those methods we talked about to be able to track down the name of the function and then what the parameters mean and whether it returns an output or you pass in the output path. Okay? And I've got some other resources here as well, and like I said, there's a bunch of stuff on the web. Okay, so similar to SpotPy, you can also access the attributes from ArcPy. So similar to SpotPy. Here we've got a shapefile. Now the one thing that's different is the search cursor. And the one place this works better than SpotPy is on really large shapefiles with big, huge amounts of attributes. When you open a SpotPy shapefile, it will load all the spatial data and attributes into RAM. It just loads the whole thing. And that can take a while. Once you've got it in RAM, it's faster. But if you've got a really big file, like I've got some files with 1 million points in them, this is going to be quicker because this is a database version of a search cursor to go through a file, and it doesn't load it all in. It goes line by line through it off of the disk. So in those cases, this is probably going to be quicker. Otherwise, it's probably going to be slower. Anyway, so once you do search cursor, you get back an array of rows, and then you can go through those rows, and you can get values from them. So note that this is, for this row, we're going to go get the value that's in that row in the column identified by administration. Here we're getting the population estimate, and then we go ahead and print them out. Now, you can also go through all the values in an attribute table by listing the fields. Fields is another name for attributes. Again, it comes from the database world, but just think of a field as being a particular attribute column, and you'll be good to go. So this gives you all the fields, and you can see here for each row, we then go through all the fields, printing out the name and the values, basically going through the entire table of attributes. And then I just put up some code here for you to quickly see how to insert rows, delete rows, and update attributes in case you need it. Have fun with that.